Hello, good afternoon now. Good afternoon, everyone. I welcome all of you to the most comprehensive exam preparation app, that is BYJU'S Prep. I welcome everyone. All of you, please join together. Hello, everyone. I welcome all of you. Please join fast so that we can start our session. Hello, Siddharth, Rahul, Sai, Kavya. Welcome, everyone. Am I audible to all of you? Am I audible to all of you? Okay. One thing I would like to share, which is very important, regarding strength of material. Isn't it? See, I have found that most of the time, see, if you will ask me, obviously you will be also wondering that, or maybe you will be also, will be knowing to see which chapter is having a most weightage compared to any of other chapter, which chapter is having the most weightage. So first of all, please all of you like the session. Yes, hello Rahul, Salim, Sai, Aman, Sachin. So please, all of you, please like the session. Do not forget to like the session. Mostly I have seen that IIT Kharagpur, they are asking the question from deflection chapter. Matlab, this is just a weightage. One cannot predict that every time they will be asking from that particular chapter only the most questions. But this is how I have just, I have seen, I have observed that mostly they are asking question from deflection chapter. The percentage is quite high from the deflection chapter, that's all. And also that from the perspective of strength of material as a subject also, if you see, most of the questions generally are coming in the GATE examination from either from the first chapter or from SFD BMD or deflection, isn't it? These are the major chapters from where you will get the questions in general. Now let us start. I hope all of you have already arrived here, so do not forget to like the session. All of you please hit the like button. And let us start our session now. This is myself, and I have experience of more than 8+ years of in teaching, and you can follow me in Telegram channel, that is Civil by Ansari sir. And in a bracket maybe you'll see that that's the surgeon. So you can follow me there and you can ask your doubt anytime. So here is the first question in front of you. Can you just tell me what will be the answer for this one? These are just nominal and easy questions, 1 marks questions. 1 marks question. Is it visible to you first of all? Okay, this is quite visible. I can say that. This is just you can imagine what kind of question it is. So for this material A and material B, the stress strain diagram for the two material A and B has given for the from the first chapter only, isn't it? The following statements are made based on the diagram. Material A is a more brittle than material B, and the second statement is the ultimate strength of the material B is more than that of A. Obviously, it is very obvious to see that whenever you have a ductility, this material is more ductile. The material B is more ductile, so material A is more brittle than material B. Obviously, if material B is more ductile, it A is less ductile, or I can say that it's more brittle. That is correct statement only. The ultimate strength of the material B is more than that of A. That is actually wrong. The ultimate strength of the material A is higher than the material B. So here, if you go see, that is 1 is true but 2 is false. Very easy question. Very easy, isn't it? Now, what is the dimension for the flexural rigidity of the beam element in MLT? What will be the dimension for the flexural rigidity of the beam element in the MLT format? What will be the question? What will be the answer for this one? What will be the answer for this one? So here the dimension for the flexural rigidity, that is EI. EI. What is that? You are writing down that Newton per meter square. That is your E, and then you have a I. Flexural rigidity means what? EI, no? EI, isn't it? Newton per meter square, then m raised to 4. So I am just writing down Newton is what? That is force. Force is what? Force, what I will write it down? That is m L T minus 2, isn't it? Force, already we know that m L T minus 2, and this is meter square, and meter 4 you will get what? L raised to 2. Finally, what you will get? M L3 T minus 2. Easy questions sometimes they used to ask, although it was for 1 marks only. Next one, for the state of stress shown in the figure below, the maximum shear stress will be. What will be the maximum shear stress? What will be the maximum shear stress? What will be the maximum shear stress here? See, at least for 2D, you know that this is the maximum condition one can imagine about, isn't it? There is nothing more than that one can ask. So maximum shear stress, either you can calculate through the Mohr circle, or you can directly utilize your formula. Or directly you can utilize your formula, isn't it? In Mohr circle, what is that maximum shear stress? It is nothing but radius of the Mohr circle, isn't it? Radius of the Mohr circle. Or those who have studied strength metal, I generally used to say that it is quite easy sometimes. If you can remember the formula also, it will always help you a lot. Sigma x minus sigma y by 2 whole square, then plus tau x y squares. That's all. You have a sigma x which is compressive, you can take it as a negative sign, no problem, isn't it? Just put the value here, that is minus of 2, then minus of sigma y given, that is 4 divided by 2 whole square, then plus tau xy is 4. Tau xy is 4 square. So under root, how much you'll be getting here? 4 means 4 2 6. This is both are minus. 4 2 6 divided by 2, 3 square plus 4 square, obviously 5. Maximum is 5, that's all. Maximum is 5 MPa. The value of axial stress in kilonewton per meter square and bending moment in kilonewton and shear force in kilonewton acting at point P for the arrangement shown in the figure are respectively. And fortunately, this is cable. This is a cable. Cable are not capable of providing any bending moment or shear force, isn't it? But he's asking the value of axial stress. He's asking value of axial stress, bending moment at P, not in the cable, at the support he's asking about. At P, what is the axial force? What is the bending moment? And what is the shear force? What is the shear force? Now this is your cantilever. This is your cantilever beam. First of all, axial stress, if you will calculate. The axial stress. See, if it is frictionless pulley, of course, you are going to get the tensile stress here, isn't it? You are going to get the tensile stress here, and that tensile stress directly can be converted for the axial stress, right? That tensile stress which you are getting it, if you draw the free body diagram for this cantilever beam, just a moment. If you draw the free body diagram for the cantilever beam, what type of diagram you will be getting it here? So draw it. One second. Here you have a frictionless pulley, right? When you have a frictionless pulley here, this downward load 50 kilonewton will be acting here. Why? Because you have attachment, the rope attachment here. So away from the touching point, there is a 50 kilonewton which will be acting. Then it will be acting 50 kilonewton at this location, right? and 50 kilonewton it will be acting at this location due to the cable here. 50 kilonewton will be acting at this location for this support, right? If you'll calculate the axial stress here, for the point P, the axial stress, if you'll calculate, how much you'll get? It will be 50 divided by what is the area? Area is not given. There is area is given for the arrangement shown in figure. Oh, area is given, sorry, 0.2 by 0.2, 0.2 by 0.2. So axial stress you will be getting around 1 to 25 and 12.5. So 1250 kilonewton per meter square. Even though if you will not calculate anything else, you can directly see that axial stress you have only one option there, axial stress, right? You have only one option for the axial stress here. Now if you will calculate the bending moment at this location, what is the bending moment you will be going to get it here? The bending moment at this location will be 50 into that distance 15, that 150, that's all. And shear force every time you will be looking for it, that is 50. For the beam, actually if you see, the shear force is 50 and bending moment 150. Simply 50 into the distance, and this 50 is the every time if you take the section, you will find out that 50 is the transverse load. Summation of all the transverse load will provide you the shear force, that's all. Now what about this one? A frame ABCD is supported by a roller at A and on a hinge at C is as shown. The reaction at roller end A is given by. Oh, he's asking, this is A. So some reaction will be there. What is the reaction at A? The reaction at A, of course this is a roller and you will be having only reaction perpendicular to the normal to the surface, only one reaction you will be getting it, right? Now you can go for the summation of moment at C equal to 0. Summation of moment at C must be equal to 0. If you do that, how much you will get? See, RA into this distance is the line of action. If you increase the distance here is L. RA into L, it is rotating about me. You are standing here and about you it is rotating maybe clockwise. So I am taking plus. Then this P into this length is L by 2. So I am taking minus of P into L by 2. And then this P into L by 2, this is plus P into L by 2. Must be equal to 0. So these two will get cancelled and finally you are going to get RA equal to 0. Very easy question. That is why it was for only 1 marks, isn't it? A simply supported beam AB has a bending moment diagram as shown in following figure. The beam is possibly under the action of following loads. Okay. I don't know why they have asked 2 marks question. Why they have asked this for 2 marks? You know that for whenever you are drawing the SFD, 2 points you are keeping inside your mind. That is for SFD diagram. Sudden change you are getting for the concentrated load, है ना? Concentrated load. And for the BMD, the sudden change you are getting it due to the concentrated moment. Now as you can see, if it is a bending moment diagram for the simply supported beam, of course you have a 0 here and 0 here, which may be of support at this location. Now after that you have a two sudden change in your bending moment. The change is from 0 to m. The value is given as m, and here it is from plus m to minus m. So total change here is 2m. If you draw the diagram, if you draw the beam here, suppose simply supported beam, you can easily identify at C and at D you have one moment acting here with the magnitude m. That is why you are getting a sudden change of from 0 to m. The total change of the moment will be reflecting the amount of the moment which is acting at that particular location, and here the total change is 2m which is acting. So total change is from plus m to minus m. So total moment change is nothing but 2m which is acting at this location. That is why you are getting the sudden change. So m is acting at C and 2m is acting at D. That's all. Now pick the incorrect statement here. Pick the incorrect statement from the following four statements. On the plane which carries maximum normal stress, the shear stress is 0. On the plane which carries maximum normal stress, the shear stress is 0. That is quite okay, no? Correct only. Because when you are drawing the Mohr circle, the principal stress you are getting, principal stress or principal plane you are getting on the basis of shear stress 0 only, isn't it? If the shear stress is 0, that plane we are calling it as principal plane, and the principal stress which you are getting there, that is the maximum and minimum, that is your shear stress is 0. So that is correct. Principal plane are mutually, so he is asking about which is not correct. Principal planes are mutually orthogonal, that is also correct. That is also correct. They too have 180 degree, and you know that from the real element, if you will see, if you have a theta here, it is 2 theta, so it will be always mutually perpendicular planes. Then this is also correct. On the plane which carries maximum shear stress, the normal stress is 0. That is not at all correct. See, here I can show you same. This is tau and sigma. This is tau and sigma. You have a maximum shear stress, but can you see that you have still a normal stress here? That is not at all correct. One cannot ensure that, one cannot say that for the maximum shear the normal stress will be 0. So C is the answer which is not correct. The way he is asking, actually he is asking about which is not correct. So these all are correct, and this is the one which is not correct, which will be the answer, isn't it? The Mohr circle for the state of stress defined by. The Mohr circle for the state of stress defined by. What will be the Mohr circle for this state of stress? What will be the Mohr circle for this state of stress? This is also very simple, isn't it? This is also very simple. Can you do that? Several times I told you, whenever you will get the, first of all, see, for 3D stress, what is the representation? Sigma x. See, first of all, that is plane. Normal to the plane acting in x direction. Normal to the plane acting in y direction. Normal to the plane acting in z direction. Then stress normal to the plane y acting in x direction. Stress normal to the plane acting in y direction. Stress normal to the plane y and acting in z direction. Then stress normal to the plane z acting in x direction. Similarly in y direction and in z direction. That is the 3D total 9 stresses to define. When you are defining the stress at a point, 9 stresses will be required, whereas already you know that due to the moment equilibrium, these two will become same. Then these two will become same. It means equal, and these two will become equal for the moment equilibrium. So only 6 stresses will define. So this is the way you are defining for the 3D stress. And for the 2D stress, how you are defining it? That is nothing but this one. For the 2D, that's all, this one. Sigma xx, sigma yy, sigma xy and sigma yx. That is tau xy actually, shear stress, right? Now shear stress already has a 0, and sigma x and sigma y you have only. So what is the state of stress? What is the state of stress here? If you see the state of stress here is nothing but state of stress. You have a sigma x 30 and you have a sigma y 30. That's all. So they are representing this sigma x and sigma y in matrix format. That's all. This is another way of representation. That's all. Nothing else. Now, what will be your Mohr circle? If you draw the Mohr circle for this one, first of all, as I told you, see the stresses which are acting on the vertical plane. What are the stresses acting on the vertical plane? Write down the coordinate. That coordinate is nothing but 30, that is tension, and no shear stress, that is 0. So first coordinate you got it. Then what are the stresses acting on the horizontal plane? On a horizontal plane. So stresses acting on the horizontal plane are nothing but 30, which is tension. So I will take plus, and then there is no shear, so it will be 0. Now going to construct the Mohr circle, you will see that this is your sigma and this is your tau. Now draw the Mohr circle for this one. You have a 2 coordinate, that is 30, 0, 30, 0. You will get a simple point, that is 30 and 0. Now you observe whatever is correct here. Center at 30, 0. Obviously center at 30, 0 without radius. The radius is also 0. No Mohr circle can be constructed here with the single point. No Mohr circle can be constructed. So the answer will be D. That's all. For the given shear force across the symmetrical I section, the intensity of shear stress is maximum at. See, this is actually occurred in 1994, but in 1994 also they have actually conducted the exam. This question I have taken. See, for the I section, they asked twice. So for the I section, actually, if you see, you already know that. Where is the maximum for the I section? The maximum shear stress variation, already you know that. Just a moment. Shear stress variation for the I section. What is the shear stress variation for the I section? this is the shear stress variation. Here as the width get changes, suddenly the width reduces, the stress will get increase, and once again the parabolic variation, the reduction of the stress due to the increase in the width. This is the total stress variation. I'm sorry if the diagram is not much appropriate, but yes, this is the parabolic variation, and maximum shear stress is going to occur at the center. Now what he's asking, for a given shear force across a symmetrical I section, symmetrical one, the intensity of shear stress is maximum at, obviously it is at the center of the section, that's all, isn't it? What about this one? A beam with the cross-sectional given below is subjected to a positive bending moment of 16 kilonewton meter. So there is a bending moment 16 kilonewton meter acting around the horizontal axis. The tensile force acting on the hashed area of the cross section. Now he's asking about the tensile force. This is the one actually which needs some calculation at least. Needs some calculation. You know that whenever you have a section, the bending stress variation. What is the bending stress variation across the depth? The variation of the bending stress across the depth is, if bending moment he's saying that causing a compression at the top. So at the top it is compression, at the bottom it is tension. At the bottom it is tension. So this is the variation of the, and where is the neutral axis for this one? The neutral axis for this one is at this location. This is the mid of that, no? So just draw this line. Now this is the variation of the stress, bending stress across the section, across the depth. Now across the depth, if it is like this, how you'll solve this one? See, I know the bending stress at neutral axis is 0. So at this side it is 0. What is the bending stress at, this section? So if you will be able to calculate the bending stress at this section, then what you'll do? Now stress variation from here to here, the stress variation is linear, isn't it? If it is linear, what I can do? The stress variation is linear, and you, just a moment, I'll just draw the diagram. This one, actually this question I like to represent. This is linear one. Now, as per the variation, if you'll draw the shear stress from this, this variation, I'll just draw it for the tensile zone. Although he is not asking over whole area, but this is the way it will vary, isn't it? This is the way it will vary. The total bending stress will vary. Here it is 0 at the neutral axis, and here it has some value. Now what I'm saying, that the area here given is this one only. Suppose this is the area. First of all, you calculate the stress. Once you know what is the stress, you can simply multiply with the area and you will get the total force. What stress you will take, as it is varying linearly across the depth, which stress you will take. So if you are standing here and if you are looking at this location, this is the variation. Instead of that, what I can do, calculate the bending stress at this location, sigma, and here it is 0 already. So 0 plus sigma divided by 2 is the average shear. You can take the average stress, and multiply that average stress with the area you have. The area you have is nothing but 25 into 50. Can you see that? 25 into 50, that's all. That will give you the total force which is going to act over this particular hashed area. That is going to give you the total force which is going to act over the particular hashed area, isn't it? Are you able to understand that? And to get the bending stress, how you will calculate the bending stress? Just bending stress is nothing but m by I into y, isn't it? What is m? M already is given as 16 kilonewton meter. Just change it to 16 kilonewton to Newton and meter to mm. Then divided by I, that is b dq by 12. So b dq by 12. What is b? B is 100. B D is total 75 plus 25 plus 50, that is 150, VD cube by 12. So 12 you multiply over here. And what is your D by 2? What is your D by 2? Now, sorry, D by, what is your Y? So actually I am interested to know the bending stress at this location. So what is my Y value from the neutral axis? What is my Y value from the neutral axis? That is 25. So multiply with the 25, isn't it? And after multiplication and all calculation, you will get around 14.22 Newton per mm square. Newton per mm square. That is the bending stress. Once you will get the bending stress, the total force can be calculated easily. The total force, tensile force, as I told you, total force 0 plus sigma by 2. That 0 plus 14.22 divided by 2 into 25 into 50. Still it is, you just understand it is in Newton. It is in Newton. Yes, it is just only in Newton. If you will calculate, how much you will get? You will get around 8.88 into 10 raised to 3 Newton. Just if you convert it to kilonewton, you will get 8.88 kilonewton. 8.88 kilonewton. Did you get that? Now what about this one? If a beam of a rectangular cross section, please tell me if you have any doubt here. If a beam of rectangular cross section is subjected to a vertical shear force V, the shear force carried by the upper 1/3 of the cross section is. What is the problem here? This needs actually a little bit of, once again, calculation. Why? See, you know that the shear stress distribution for the rectangular section will be, parabolic, isn't it? Across the depth, the shear stress distribution is parabolic. Now he is asking how much force will be carried by the 1/3 portion, top 1/3 portion. How much force will be carried by the top 1/3 portion? That is what he is asking. But first of all, we actually know that the shear stress is totally varying all over the depth. So what we'll do, how you will calculate? So take some from top, you take some x height or y height, something, and take some dx element and find out what is the shear stress here, and due to the dx element, what is the total force created by that, right? Very thin element I am considering that dx. You find it out what is the shear stress at depth x. What is the shear stress at depth x? If you will calculate, how much it will be? Just a moment. See, earlier in a bending stress also, I just told you when it was a linearly varying over the plane, when it was linearly varying. See, if you have a plane and directly if you have normal stress, stress which is not at all varying, the constant stress, if it is acting, simply stress into area will give you the force, correct? No? Earlier, then in the previous question, the bending stress was there, which was varying linearly. So what methodology we have adopted? We have taken that average of these two and just multiplied with the area. Now this time actually it is not linearly varying also. Are you able to understand that? This time it is not at all varying linearly. So that is why if no linear variation is there, then we can go for the integration, right? We can integrate it. Otherwise, so first of all, find it out what is the shear stress acting at a depth x. What is the shear stress variation, first of all, isn't it? Now if you calculate the shear stress at x, what will be that? So shear stress is what? VAY bar by IB, correct? No, VAY bar by IB. What is your VAY bar? So V and area for this one. See, if I am calculating what is the stress at this location, shear stress at this location, then area above that will be considered. Area above that portion will be considered. This area will be considered, isn't it? Now what is the area here? X into B, that's all. Area is X into B. And what is the Y bar? So centroid of this, the distance from the neutral axis. What is the centroidal distance of this area? What will be that one? This is nothing but, see, this is d by 2, I can get d by 2 minus x by 2 divided by what will be the moment, moment of inertia, that is b dq by 12, b dq by 12, then multiplied by b, isn't it? Just if you simplify, you'll get vbx and wait, this 12 will also go, so 12 will become 2. If I'll take common, it will become 6, 6. Just simplify this one, 6vx, and bb will get cancelled, and here if I'll taken, so it will become d minus x, half I have taken common, then divided by, it will remaining, vb chala gaya, bdq will be remaining. Okay, bdq. This is the shear stress at this portion, the variation of the shear stress just we have taken out, right, in the direction of x. Now what will be the force created by the element thickness dx? What will be the force created by the element thickness dx? So total force which will be created by the element thickness dx, I can write it down. This is the shear stress, and the area of that dx element I can write down. See, shear stress tau x into the area is how much? Area is simply width and dx, that's all, b dx. Agree, no? Agree or not? Now what is that? Write it down, 6vx. So here you will get 6v x d minus x divided by bb will get cancelled, so I can write down directly dq and dx. That is your force created by this small thin area dx. Thin area, matlab width, that area I have taken dx. Now if you are interested what is the total force created by the 1/3 top area, integrate it from 0 to d by 3. Integrate it from 0 to d by 3, isn't it? 0 to d by 3, top 1/3 area, how much force they are creating, integrate the whole from 0 to d by 3 and you will get the, so just integration you have to perform here, that 6v and dq, they are all constant, you take it outside, then multiply this x, so it will become x into d, and integrate also, I think better integrate also, xd, it will become x square by 2d, and it will be x cube, so it will be minus of x4 by 4, correct, no? Or any mistake if I am doing, 6vx into d minus x. No, 6vx, xd, x square by 2, x square, x cube by, this is x cube by 3, just 0 to d by 3, है ना? Now just put the value here, and simplify, and you will get the force which is created by 1/3, that will be coming around 7v by 27. Just you simplify this one, put the value d by 3, 0 to d by 3, that is the limit, you put it and you will get 7v by 27. Did you get that? What about this one? Oh. I section of beam is formed by gluing the wooden plank as shown in the figure below. If this beam transmits a constant vertical shear force of 3000 Newton, the glue at any of the 4 joints will be subjected to a shear force. How you will calculate that? d by 6 to d by 2 होगा, d by 6 to d by 2 क्यों होगा? It is depending on, so what, wait. Yes, you are absolutely correct. It is always dependent on the way you are taking it. Wait, I think you should understand this question you are asking. No, see, the depth I have taken it from top, that is why x I have taken here. Acha, if you want to conduct in that way, you do one thing, you take this section, no problem. From the neutral axis if you want to conduct, no problem at all. you are thinking correctly, but the problem is that if you are taking from the neutral axis reference, suppose maybe from the x, this if you take from the neutral axis, then you will go from d by 6 to d by 2. Are you getting my point? The integration will depend now, and similarly the area and everything also will depend now, right? At x distance, if you want to take that, now this area will be different because this is x, so what will be this width? It is depending on how you have taken the reference. I have taken it from the top. You are just asking me why I cannot, should I take from d by 2 to d by 6? Yes, if you are taking it from the neutral axis, then it will be from d by 6 to d by 2. Are you able to understand that? Did you get that? Okay, now what about this one? What about this one? How you will solve this one? If they are glued together, just you take one piece here and try to understand what will be the situation. What will be the situation? If you take this piece here, this piece will be this is the hashed piece, hashed location. I am taking it here. This is the hashed location. Now, whatever the shear stress, you know that shear flow, right? That is why shear flow has occurred. Shear flow. As per the shear flow, you know that the glue is actually applied at these locations. The glue is applied at these locations here. So calculate the shear flow. These two will be same, no? These two will be same. Calculate the shear flow by considering this one, and you will get the shear flow for this one. That is the how you will get the one which is asking about. Because glue actually you are applying at this location. You are applying the glue at this location, but these two shear will be same. These two shear stress will be same, isn't it? Now, what is the formula for shear flow? That shear flow is nothing but, that shear flow Q is nothing but per unit length, isn't it? It is per unit length. The shear flow is per unit length, which is shear stress earlier was, what was the shear stress? Shear stress was VAY bar by IB. So if you multiply by B, then you will get, okay, shear flow will become VAY bar by I. This is stress per meter square, per mm square, that is per unit area square, per unit area. This per unit length. Shear flow is your per unit length. Now that VAY bar by IB, you calculate that VAY bar by IB. What is your AY bar here? Separately you calculate what is your AY bar. What is your AY bar? So AY bar is nothing but, AY bar is nothing. What is this length here given? Area. Okay, this is 75 and this is 50. So 75 into 50 is your area, into what is your Y bar? That Y bar is nothing but, Y bar is nothing but, what will be the distance from here to here? That is 100 and plus 25. This is 125 AY bar, correct? Hence it will become, Q will become directly, or I also, if you want to calculate separately, you can write it down. Where is I directly given, or you have to calculate? Oh, that we need to calculate I. Okay, no problem. I also you calculate I. How much you'll get? I, please calculate the I value also. This is a little bit calculative, man. Okay, then first of all we'll calculate the total. Take the total box, right? BD cubed, take the complete box first of all. That is BD cubed. B is 200 and D is 50 plus 200 plus 50, 300. So BD cubed 12, BD cube by 12, and then minus, I can take minus, this is 200, 200 में से 50 गया 150, so I can take B, right? and depth is, this is 200 only, no, b d cube by 12. That's all. This will be your I. Are you able to understand that? Take the complete box, then subtract these two, and the width of already, you know, I have taken from out of 250 you remove, then you will get this width, complete width, and depth is 200. So BD equal 12. That's all. And you will get around I value, that is this much. You will get the I value. So AY bar and I value, if it is known, what is the V value? That is shear force. Shear force already given. Now just calculate the shear flow. That's all. Calculate the shear flow here. The shear flow will be V is given 3000 multiplied by AY bar, already you have calculated 75 into 50 into 125 divided by I. I is 350 into 10 raised to 6, and if you calculate that, how much you'll get here? Around 4.01, and if everything I have kept in mm, so it will be Newton per mm. He is asking in kilonewton per meter length. So kilonewton matlab you just divide it by 10 per minus 3. Okay, mm is already there, no? 1 mm is equal to 10 per minus 3 meter, and Newton you want to change, 1 Newton is equal to 10 per minus 3 kilonewton, so that will get cancelled, and I can directly write down it is nothing but 4 kilonewton per meter. 4 kilonewton per meter approximately. Did you get that? So that is the shear force on a glue per unit length. Shear force on a glue per unit length. What about this one? Now this is from the conjugate beam method, and this is quite most easiest problem, I think. These things already you can calculate. Oh yeah, everywhere it is like this. What will be this one? You will already, what is the conjugate one? Fixed will become free, end hinge will be as it is end hinge, internal roller will become internal hinge, and it, first one is the correct one, that's all. First one is the correct one. Internal hinge will become internal roller, so first one is the correct one. Free, that's all. What about this one? For the structure shown below, the vertical deflection at point A is given by, where is the point A? I think this is point A, right? Vertical deflection at point A, I think it was the point A. Suppose how much it will be? Simply shift the force here now. Shift the force. If you shift the force, already I told you how to shift the force. Parallelly you shift it here. Parallelly you shift it. How much you'll get? Parallelly shift it and just stand here and you see what this force is doing. It is trying to rotate. It is trying to rotate like this. That's all. This rotation already you can provide it here, and this force also is axially one. So this just, that's it. P into what is this length? 2L. This is P into 2L, and the force is P. So for the cantilever, simply what you are getting here, for the cantilever you have a P force and a moment here, that is nothing but P into 2L. That's it. That's it. Once you are able to write it down like that, then it is easy, you know. He's asking what is the deflection at point A. So due to the concentrated load, downward deflection you will get, that is PLQ by 3EI. So PLQ by 3EI matlab this is 3L. So PLQ by 3EI downward deflection. Then upward deflection you are going to get, upward I will take as a minus. This is a moment, and upward deflection due to the moment is nothing but ML square by 2EI. What is M? M is P into 2L, that is M. L square. L is what? 3L square by 2EI. 2EI. Okay. Now how much you will be getting it here? Just see that 3 3 6 3 9 27 so 27 by 3, so you'll get 9 P L cube by EI, and here you'll get 3 3 6 2 12 2 6 6p. Is it correct I'm doing? 3 3 9, sorry, 3 3 9 2 18, 2 9 18, you will get 9 only. 9 3 3 9, 9 2 18, 9 18 और 2 2 कट जाएगा तो only 9, then p l cube by ei. Oh, that is 0. That's all. So only if you know how to shift the force, you can calculate it very easily. If you know only how to shift the force, generally in several type of in several test series and all, or whenever I am conducting the session, I used to provide you what is the how to shift the force. Then consider the beam as shown in figure. Consider the beam as shown in figure. Part AC of the beam is rigid, while part CB has the flexural rigidity EI. Okay. Identify the correct combination of deflection at end B and bending moment at end A. Bending moment at A. What is the definition of bending moment? Summation of all the moment at any one side of your considered section. That's all. So what is the summation amount? P into 2L. P into 2L. So after seeing that P into 2L, I can identify these are the two options which are correct here. Out of these two, which is correct one? Out of these two, which one is more correct, isn't it? Now calculate what will be the, what is asking? AB, AC is rigid. Okay, AC is rigid, while part CB has the flexibility EI. Now CB has the flexibility EI. Now if it is AC is rigid, rigid means what? No deflection will occur. If no deflection will occur, only this part is going to get deflect. That's all. So PL cube by 3, that this is L, PL cube by 3. So A is the option. That's all. A is the option, isn't it? Rigid means what? No deflection you will get. So PL cube by 3. What about this one? Consider the propped cantilever beam. Consider the propped cantilever beam. ABC under 2 load of magnitude P each as flexibility of the beam A is given. This is also quite easy. You can use your compatibility condition to get the reaction. He is asking the reaction here. So use the method of consistent deformation or compatibility, whatever you say. That is reaction at RC. Right? Here you have a reaction that is RC. Maybe. Now what will be the RC reaction? You can simply so you have a reaction here and you have a moment here. The moment is, what is the value of moment? P into this distance is 2A. Okay, P into 2A. Anna? This is P into 2A, and here you have a reaction that is RC. Now what you will get, the is asking reaction, no? So just do the compatibility condition, the deflection at C. You know that is a support, no deflection will be there at C. No deflection will be there at C. So due to the moment P into 2A, what is that C? Due to 2A. So split it in two part. Split it in two part. So I'll just remove this one. Calculate what is the downward deflection you will be getting. Downward deflection you will be getting due to the moment. Due to the moment here, this will be straight, no? Remember that will be straight from here to here, because no bending moment at this location. From this point to this point, it will remain straight. I'll use another color, you will understand this. This is very nice. This will get bent, and here after that it will be straight. It will be straight only. So the downward deflection you will be getting it only due to the moment that you need to calculate, and there also this deflection is due to the moment which is length L. So the deflection is ml square by 2ei, and here the deflection will be r theta. These two I will be adding it here. That is the downward one. Then plus due to the reaction, what is the upward? What is the upward deflection? Due to the reaction. That is maybe another deflection. So maybe these two together if I write down, or maybe delta 1, delta 2, or let us take this one as delta 3. This delta 3 is due to the RC. So write down the compatibility condition now here, which is, you already know that the downward deflection and upward deflection equals 0, because this is a support and you are not going to get any type of deflection here, isn't it? Now what is delta 1? Delta 1 is simply moment which is applied here over the beam at B location. Length here till here, why is given? Maybe this is some misconducted diagram. Maybe this moment will be here only. These two are at the same location, otherwise why the length will be given, right? So if you have applied the moment at this location, what is the deflection at this point? So deflection will be ml square by 2ei, right? Deflection will be ml square by 2ei, and so just write it down, ml square by 2ei, and plus r theta. R theta means this is L into theta at whatever you have theta at B. Then this is the downward deflection. Suppose downward I have taken minus, the plus, so minus, upward I will take minus. Upward is due to the reaction only, which is PL cube by 3i. So RC into L cube. L is 2L. You just make sure that you are using the correct length and all. PL cube by 3i for the cantilever. PL cube. So 2L cube by 3ei. That must be equal to 0. That's all. Isn't it? Now, if you solve this one from here, simply you will get m. You already know that what is the value of m. Value of m is p into 2a. What is theta? Theta also you know that ml by ei. So should I write down theta here? This is p into 2a or 2pa into L square divided by 2ei plus L into theta is what? ml by ei. M is what? P into 2a m, and then L by ei, then minus of this whole RC 2L cube by 3ei equals to 0. If you solve this from here, you will get the RC value, which is 5 by 16 PAL by ei. That's all. 5 by 16 PAL by ei. Oh, he's asking rotation, not the reaction. I'm sorry. Where is the reaction? He's not asking. Oh, I have already skipped that one. Here it was asking reaction. I'm sorry for that one. Another slide actually I have taken for that one. Simply I have just skipped it. I don't know how. Rotation is the next question. So I'm sorry, here I have calculated the. So now you got it, right? So reaction I have taken as an upward, that is RC, and reaction I got it 5 by 16. No, 9 by 8. Just a minute. Just calculate it first once again. Calculate it once again. How much I am getting here? Once again, 2PA L square by 2 will get cancelled. 2 will get cancelled, and you will get here EI plus 2PA L square by EI, then equal to RC L cube by 3EI. So EI you take out, sorry, EI only will take out, 3 will remain here, then PP will go away. No, P is there, no, P will not go away, sorry. What will go away here? L square will go. So I'll write down P into A and plus 2PA, correct? L square has gone, so it will become 3PA equal to RC into 8L by 3. So it will become 3 and 3 no 9PA by 9PA by L. RC will become 9PA by 8L. RC will become 9PA by 8L. 9PA by 8L in upward direction. Okay, that's what I'm getting. I'm really sorry for the calculation. I just did the wrong calculation earlier. 9PA by 8L in, that is the RC, that is upward reaction. Then you calculate the rotation also. Then you calculate the rotation also. So reaction just I have calculated in this slide, I'm sorry. Rotation also he's asking at point P. Rotation also can be calculated by using the same, you know, method of superposition. You can simply apply there, isn't it? 9P by 8L I have calculated. Okay. So rest of the questions also, lot of questions are there. Due to the some time restrictions we cannot solve all the question, but you do not forget I will be taking all the question. I will be taking some extra class for, you know, already this IIT Kharagpur series is going on, so extra class I will be taking, of course I will be taking some extra class to conduct that. Maybe at the end of that we'll take the extra class and we'll complete all the questions for the IIT Kharagpur asked. But mostly you will see that the percentage or the weightage of the questions are from deflection chapter. The weightage of the most questions are from the deflection chapter. Now that is what I can see, but one cannot be assured that every time they'll be asking from the deflection only. This is from the previous experience, just I'm sharing with all of you. So thank you everyone for watching the session, and please do not forget to like and share with your friends. We'll meet once again for the next session. Thank you.